Hello, today we're going to be working with standard form, and it's just another way of writing a linear equation. We have learned about two others, and we're going to be adding this third one with it. So we've seen that the standard form of a linear equation is ax plus by equals c, where a and b are not both zero. One of them can be 0, but not both of them. For instance, in the equation 2x plus 3y is negative 12. 2 would be A, 3 would be B, and C would be negative 12. You'll also notice that the A, B, and C are all in capital form, and that X and Y is in lowercase form. We can write equivalent equations in the slope-intercept form and point-slope form. For instance, an equation in slope-intercept form and the equation in point-slope form are shown. So here we are. We have it as 2x plus 3y equals negative 12. And this same equation, if I reorganize how it's set up and get y by itself on the left, I can rewrite it as y equals negative 2/3 x minus 4. And so we'll go ahead and do that now. So we have 2x plus 3y equals negative 12. And my goal is to get y by itself and and positive on the left. So the first thing I'm going to do is I'm going to move my 2x to the other side. So then I get 3y on the left, and on the right I'm going to have negative 2x minus 12. Now to get y alone, we have to divide by 3. And so when we divide that by 3, we divide everything by 3. So that becomes 1. Negative 2 over 3 becomes negative 2/3. So there's our slope. And negative 12 divided by 3 is negative 4. And so that's where we get our slope-intercept. I have my y equals slope times x plus my y-intercept. Now I could also do the same with the slope-intercept form or point-slope form. Once I have my ordered pair, and I know that I can use some ordered find a value for x, and then that'll help me find my value for my y. You can do the same thing, and I think we're going to practice that here in just a moment. So we're going to create linear equations in standard form given a slope and point. So if my slope is 2 and my negative 2 is my ordered pair that is on that line, we're going to write it in the point-slope form. We're going to substitute the given slope and the coordinates of the given point. And so we get y minus 2 equals 2, that's my slope, minus my negative 2, x minus my negative 2, which we know ends up being add 2. I can distribute, so I'm going to 2 times x is 2x, and 2 times 2 is 4, so that gives me my y minus 2 equals 2x plus 4. So this is a simplified point-slope form. So this is my point-slope form, and this is simplified. Now I can easily rewrite that in my standard form by just moving my x to the left and moving my 2 to the right. So I'm going to take my y minus 2 equals 2x plus 4. And that's what I got right here from this simplified form. And I am going to add my 2 to both sides. So I get y equals 2x plus 6, which happens to be my slope-intercept form, correct? So now I'm going to take and I'm going to move my 2x over to the left. And because we know that it is ax plus by equals c, I want the x term to go in front of the y term. So I'm going to subtract 2x from both sides. And I am going to then have negative 2x plus y equals 6. Sometimes they prefer to have the standard form with the very first, and I made a mistake here, I gotta fix this. That should be negative 2y, or 2x, sorry, negative 2x. sometimes they want that first term to be positive. And if they ask for the first term to be positive, then you would divide everything by -1 or multiply both sides by -1. And in that case, you would have 2x minus y equals -6. But if it doesn't ask for it to be done that way, this is considered the correct terms. We can use a slope-intercept form, which we did here, because we had it here, also to write it in our standard form. So we had our slope-intercept form was y equals 2x plus 6, and we just moved our 2x to the front, and we get -2x plus y equals 6, which is the same as we have here. Okay, let's see. Let's go to the next. So if we have a slope is 5 and a point -2,4 is on the line, we want to write it in the point slope form. So we know that it's y minus our y1, and in this case is 4, equals our slope, which they told us is 5. And then we have x minus our x1, which is -2. And I know that I can change that to plus 2. Now, if I simplify this, I get y minus 4 equals 5 times x is 5x, and 5 times 2 is 10. And now I can rewrite that in standard form, where I take y minus 4 equals 5x plus 10, and I move my 5x out front by subtracting it from both sides, and I add my 4 to both sides, and that gives me 14. So I'll get -5x plus y equals 14. We can use the slope-intercept form and substitute the slope and point into the equation to solve for b, because we know our slope, so we know we have y, and then we have our slope is 5 times x plus b. And if I substitute in my ordered pair, which is 4, y is 4, -2 is x, 5 times -2, that's -10. Add 10 to the other side, we get 14, so b is 14. So then we get y equals 5x plus 14. Then, so I can take that y equals 5x plus 14, and I can simplify that by subtracting my 5x from both sides. -5x plus y, oops, I already have an x there, equals 14, and there it is in standard form. My ax plus by equals c. So I want you to try this. I want you to write the equation in standard form for each line. And because we have shown that when you simplify your point slope, you get your y-intercept, it doesn't matter which way you go to do it. Okay? So on number 4, write it in standard form. When you finish, you should have -2x plus y equals -24. Go ahead and look at number 5 and write that in standard form if you know that slope is 4 and the ordered pair is -30. Because I knew that subtracting 0 from y does not change y, I have y by itself. I distributed 4x plus 12, and then I moved my 4x over, so I have -4x plus y equals 12. Okay, this will begin our second video.